Let us study what are measures of central tendency today. A measure of central tendency is a single unique representative value calculated for a group of data. It will be a single value which will represent the entire set of data, maybe thousands of numbers, such that the values within the data set will be scattered or spread around this central value. The most commonly used measures of central tendency are mean, median and mode. Mean, which is also known as arithmetic mean or average, is the central value around which the observations are scattered. Median is that value which divides the observations into two equal halves when the observations are arranged in the ascending or descending order. And mode is that observation which occurs most number of times or the observation which comes with maximum frequency. Now these mean, median, mode or measures of central tendency can be applied on data which can be divided into three types: raw data, ungrouped data or grouped data. A raw data is just a set of numbers put one after the other or separated by commas. Ungrouped data will be a set of numbers each occurring with some frequency. Raw data can be converted to ungrouped data as well as ungrouped data can be converted to raw data. The conversion shall be shown in the next videos that will come. A group data will be a group of numbers with frequencies. A raw data can be converted into a group data. Calculation of mean. Mean can be calculated as sum of all observations divided by the total number of observations. That is the ratio of sum of all observations to the total number of observations. For raw data, this can be calculated as summation xi upon n, where x1, x2, xn will be the n observations and mean is generally denoted by x bar. For grouped or ungrouped data, where you will have values x1, x2, xi, xn and frequencies f1, f2, fn correspondingly, mean will be calculated as summation fi xi upon summation fi. For group data, xi will be the class mark and for ungrouped data it will be the actual observation is the only difference. For the calculation of median, median is the value which divides the data into two equal parts when the observations are arranged either in ascending or descending order. Now for raw data, when we have n observations x1, x2 up to capital N arranged in ascending or descending order, median is calculated differently for odd observations as well as even number of observations. If the number of observations that are arranged in ascending or descending order is odd, that is capital N is odd, median is obtained as n plus 1 by 2th observation. Similarly, when n is even, median is obtained as the average of the n by 2th and n by 2 plus 1th observation. For ungrouped data, we need to calculate the cumulative frequencies corresponding to each frequency, the less than type cumulative frequencies. Now, if capital N is sum of all the frequencies, median will be that observation xi which corresponds to the cumulative frequency which is just greater than n by 2, that is half of the frequency. For group data, median is calculated as L1 plus L2 minus L1 into n by 2 minus Cf upon f, where L1 and L2 are the class limits of the median class. Now, median class is obtained or identified as the class interval corresponding to the cumulative frequency just greater than n by 2. N is the total frequency. The cumulative frequency in the formula will be the frequency of the pre-median class. You can easily look at the table, and F is the frequency of the median class. So these are the four values specifically which we are going to consider in calculation of median. Mode is that observation which corresponds to the highest frequency. For raw data and for ungrouped data, it can be obtained merely by observation. For group data, mode can be calculated as: first, the modal class is to be obtained as the class interval corresponding to the highest frequency. If the frequency corresponding to modal class is considered as F1, the frequency of the pre-modal class will be denoted by F0 or F0, and frequency of the post-modal class will be denoted by F2. In that case, mode is given as L1 plus L2 minus L1 into F1 minus F0 whole upon 2 F1 minus F2 minus F0. Thank you.